Hello, this is Rolf O'Grady with Mocana. I want to thank everyone for taking the time today to join us. I guess we'll probably still have some folks filtering in, but the first part of this will be a little bit of housekeeping stuff. So ultimately, we're going to be recording this anyways, and we will be sending this out to the folks that have registered. So for those on the call, or for those joining the call late, they can always rewind and watch the video at a later time. So basically, the two basic things I really wanted to chat with about today is really just sharing some of the common challenges that we're seeing, or I personally am seeing out in the marketplace today around industrial IoT or IoT itself. And then just given some of those common challenges, what are some of the areas that Mocana can help solve those problems? So those are really the two high-level objectives. As we go through the presentation, if you have any questions, please feel free to post them in the chat window. Happy to take those as they come along. If it's timely for the conversation, otherwise I'll call Gunny sack them and come back to them at the end of the presentation. And then you can always send in requests via email to info@mocana.com. I will happy to respond that way as well. And then just something a little briefly about myself. I've been in the technology sector for coming up on 30 years now. Most of that time has been spent in a pre-sales, customer-facing, engineering type capacity, and of that, the bulk of it's been spent in IT security or data communication security, and I've been in the operational technologies security realm now for coming up on a year. But ultimately, there are some very stark differences between security in an IT world and security in an OT world. So I'm not really going to get into the differences between the two, but rather focus primarily on the operational security aspects. So the areas that I see the more common questions around are really on the devices themselves. One of the more frequent challenges that customers have expressed or prospects have expressed is how do I deal with this pre-shared key problem, common username and password, self-signed certificates? Ultimately, how do I really better uniquely identify my device, either at the time of manufacture or at the time that the device has been installed? And that really seems to lend itself to is how do I make sure that device is not compromised or hasn't been cloned, and the applications and data coming from said device can be trusted. Another more common one is actually just understanding where all of the devices are located, what versions of code they're running, when's the last time that they were updated. I was surprised to find that actually seems to be a more common request that I run into. And then another one is not so much a question as it is an objective, but as I'm going through an updating process, if I need to put bits on the box or modify configuration files, how do I know that what I want to land on the device is actually that which is landing on the device? And then as we go farther out into the protect and measure realms of these types of infrastructures, I start hearing other questions about, okay, how do I actually make my device more tamper-proof or tamper-resistant? Or basically, how do I end up protecting my device? And then for some devices, actually a large percentage of devices that get deployed today have some form of hardware or software based root of trust. So actually, some of the questions I get are really around how do I actually leverage that which is already on the platform? And then long-term vision stuff is really how do I get more information or data off of the device itself? If I have a device that's running in the environment, what can I get from the device? Is it running hot? Did somebody try to plug a USB stick into it? Did somebody try to connect to a Bluetooth antenna? What diagnostics or information can I get or capture from the device? So from our perspective, there's a lot of technologies out there in the marketplace today trying to solve some of these challenges around device security. From our perspective, our whole premise is really it's better to protect than to detect malicious activity. So I guess stated another way is that we can block almost all of the malicious activity related to a device that really minimizes the need for detection technologies. I'm absolutely a firm believer in that you absolutely do require capabilities around auditing of traffic, validation of traffic, separation of traffic based on traffic types. So those are absolutely needed technologies. It's just that our primary focus is really on the device itself and how do we go about protecting the device. And as we go through this, what we'll see is a little bit about, it's not just putting something on the device. That could be non-trivial, but that to me is something that's a set and forget, and this is not a technology that one can set and forget. So what ends up becoming critical is how do I deal with the life cycle of the device and the life cycle of security management of that device. If I'm using cryptography as an example, cryptography is only as good as the keys I'm using, the frequency with which I rotate them. So how can we help with that? And then one of the other big drivers from the customer's perspective is still really around standards. Whether it be NIST, IEC, FIPS, GDPR, IIC. I just came back from a trade show recently in Europe, and GDPR and Industry 4.0 were top of mind for folks that were coming by to visit. So ultimately, that's driving a lot of the challenges that folks are trying to address from an IoT infrastructure, or just infrastructures in general, but in an IoT world, that becomes a little bit more challenging for many reasons. So whatever the reason or the motivation for looking into different types of technologies, like I said, for me, it's really also more importantly about the life cycle of the device and how we can help with that challenge. If I look at the devices in a different way, or if I look at it from a kind of a phased approach to solving challenges, as I mentioned earlier, the gateway or the box that's connected to an untrusted world is the first point that folks want to start solving some problems. And some of the common themes here are for greenfield deployments. I hear things, customers wanting to basically being able to just drop ship a device, do some zero-touch or very low-touch provisioning. Basically, I want to plug it in, power it up. At the time of power on and initial connectivity, I want to securely identify the device. Once I've established secure communications, I want to make sure that the operating system is running at the desired versioning level. I want to make sure that any updates that are needed are applied. I have an application that's running on there. I want to make sure that application is up to date. I want to make sure that connectivity is verified back to the server or data collection entities. But basically just want to be able to address all of those challenges on a device that's being deployed for the first time. For systems that are already deployed, it goes back to the things I was mentioning around lifecycle and security management of the device. I need to make sure that the operating system is properly patched, all firmware updates are completed, I have a record of those updates taking place, and like I said, future state may want to actually start also pulling some information off of those devices. Here I'm just depicting a smart factory, a smart building. I'm not trying to pigeonhole this, but the other challenge that I've seen here is the connectivity out of that gateway. On the front end, it's typically to be some Ethernet or most commonly probably Ethernet coming out. But on the back end of that, then we'll start to see interesting things like either wired or wireless connectivity. We'll see air gap systems. We'll see things like CAN bus, Modbus, proprietary serial protocols to actually connect the devices. But if my entry point is the area of greatest concern, we have some things that will help immediately. As I go farther into the environment, then the next question I typically have for customers is, what are those devices, and how much, it goes back to what I was saying earlier, how much real estate is on those devices from a hardware perspective that we can start potentially providing some value. And those questions are really mostly around, what is the hardware, the chipsets, memory utilization, available storage, operating system, etc. And then also getting a sense as to what is the risk profile for those devices. And then the final piece is for devices that are very resource constrained. We can also help, but now we're into the realm of basically building solutions to solve problems. And going back to the water pressure example I mentioned earlier, if my concern is I have high concern around the device, it comes a couple of other things, right? It becomes, is that a device that I know? Is it a trusted device? Is it my device? And most importantly, is the data coming off of that device, is it something I can trust? Because I may be consuming that data for analytics, that's one thing, but if I'm consuming that data for operations, that's an entirely different picture. So being able to, like I said, have a high level of confidence that device is the device that is under my management, and that the data coming off of it has a high level of efficacy. So I've called out a bunch of challenges, but okay, how do we Mocana help solve some of those problems? And we really have two different approaches that we can help customers with. What's the easiest way of starting with this one? So if I think about it, this kind of goes back to the spectrum I was referencing earlier. We have technologies that we've built in the form of binaries that we can just literally drop on a device. And then we have technologies that we can help customers build solutions, as I mentioned earlier. I mean, we've got, stuff running in a secure boot, nano boot realm at 16 kilobytes. We've got stuff that we've built for devices running in 60 kilobytes of CPU of memory with precious CPU cycles, doing some light, doing air quotes, military grade encryption to stuff running on a light bulb. So it's one end of the spectrum, and that's where we typically leverage our technologies that we call TrustCore. TrustCore is what Mocana is really known for, which is source code and libraries that we provide to software developers, manufacturers, to literally build solutions to problems that they're trying to address. And this comes out of 17 years, calendar years of, I don't even know how many man years that would be, a significantly large number, but this is basically 17 years of expertise. I don't know we have no idea what the actual number of devices, but I would feel comfortable in saying that software, that technology is sitting on well over 100 million devices out in the wild today. And while that's good and it's nice because I have a powerful toolkit, the downside is I've got a powerful toolkit, and what that really means is for customers to really benefit from that technology, they're going to require a decent, deep technical bench. And the challenge right now in the marketplace is that that talent pool is getting fairly thin, and it's getting difficult to retain. Not to say that this is an impossible task by any stretch, it's just that those are some of the challenges. And then the other fundamental challenge there is, as I was mentioning earlier, if I'm building a solution to a problem, let's call it I need cryptography, either for data in flight or data at rest. As I mentioned earlier, cryptography is only as good as the keys that I'm using and the frequency with which I'm rotating them. So while I'm solving an immediate problem, specifically encryption, how am I managing that over the duration or life cycle of the device? If I'm using pre-shared keys, if I crack one system, I crack all of them. So clearly management becomes a platform that becomes critical relative to managing these devices. And then the other thing that we've done is we've built binaries to help customers basically speed the time to resolution, or this could also help in the realm of managing or driving down costs associated with building custom solutions. But this is almost, in my mind, helping you, I don't want to say buy your way out of a problem, but ultimately buy your way out of a problem. And the good news here is, since we've basically used the intellectual property that we've built over 17 years, meaning we're using the TrustCore libraries ourselves to build what we call our TrustPoint binaries or clients, we're basically leveraging that which we provide to some of our customers in the form of source code and libraries. If you could go to the next one. The next slide just kind of reinforces that which I was just saying. For me, it's really a time to market, a time to solution challenge. So whether a customer or a prospect wants to quote unquote buy their way out of a problem in the form of just deploying binaries, obviously we typically go through a series of proof of concepts, field trials to verify that the binaries are indeed meeting the needs of the technical requirements as well as the needs of the customer. But bottom line, this really presents two things in my mind. One is time to resolution, really helps compress that. And then it really helps address, to me, the bigger challenge, which is how am I going to manage that device once I've solved the first problem? Because that's just a starting point, and I need to look at that in an iterative, cyclical fashion. So how am I going to deal with that through the life cycle of the device? And then trust core, as I mentioned earlier, that's a robust toolkit that we can use to help customers create, craft, build custom solutions. So this slide is really intended to kind of go through kind of some of the different areas that we can help people and are helping people today. So the first one is really at the very front end, and one that I've kind of brushed past, but it's actually quite critical in many environments, which is one of supply chain. As I'm building solutions, whether that be developing code that's going to sit on a device, modifying an operating system to enhance security posture, whether it be integrating an application with an operating system and a hardware platform, and it's coming together at a contract manufacturer. Ultimately, the bits that I'm writing and building, once I've presented them to someone else, how do I make sure that what I want to end up on the device is indeed what lands on the device? So while there's implicit trust in contract manufacturing partners, there's still an area of concern relative to once I've released code, how do I make sure that everyone that touches it in that supply chain has not been able to tamper with it? And how do I know, or how can I track who touched it at what point as that software ends up landing on the device? So once those devices are built at the factory and shipped to the customer, now we get into the question of, and I'm obviously just got done talking about this from a greenfield perspective. So whether this be greenfield or brownfield, I start to see commonality on what needs to take place. So from a technician perspective, some of the environments that we run into today typically require a technician to either go to a site. It could be a factory, it could be a hospital on a campus, it could be going to a utility, power and gas facility. But ultimately, there's someone that needs to go on site, and they're probably going to be carrying something to do their work. They may be carrying something in the form of code that they're going to put on a management control system. It may be sitting on a laptop that they're physically going to plug into the environment, or it might be software that needs to end up on a device that someone's physically going to carry and physically connect to a device. Ultimately, that's the last phase of the supply chain. How am I going to control bits that leave my trusted environment that are now going to go through both an untrusted, if not hostile environment that needs to land on a device? So we can help with that challenge as well, regardless of the complexity. So whether I'm deploying something for the first time or going out to address technologies that are already deployed, we can help with the entire supply chain. So so that's one element of it. The other one is, how do I securely identify and enroll a device and bring it under appropriate asset management? So this gets back to the challenge that many folks face on the front end is, if I'm using a pre-shared key, a self-signed cert, a shared username and password, how am I going to be able to uniquely identify that device with a high level of confidence that that is indeed a target device that is one that came from a known manufacturer or came from me as the manufacturer, either at the time of ship or at the time of deploy or at the time that it's enrolled. This process is where we can use potentially weak metrics on the device to make it a much more hardened and robust solution by lifting information to the device to provide unique keys and certificates and apply those to the device. So going back to that example I was mentioning earlier, where customers, some of our customers have actually rolled quite a bit of hardware out with TPMs as an example that have loaded. They have expressed interest or desire to be able to actually leverage that hardware, those hardware elements, either for the purposes of generating keys for the device itself, for the applications running on the device, and for the purposes of creating certificates. But now we're into a whole new realm of lifecycle management, which is, while I highly encourage that, that can be a both daunting and complex task for managing, PKI and certificates on devices. I mean, one of the common analogies I use is, for the folks in the call, how many folks have actually used an appropriate commercial certificate that you use with email or your browser, or how many folks just assume or accept the self-signed certificates that are used in, just general SSL type communication. And the reason is it's hard. I mean, I don't want to spend the time to apply appropriate certificates for the purpose of me to do something that should be fairly straightforward. So one of the main benefits of Trust Center is drastically simplifying that process. So the piece there, so I touched lightly on a lot of these things. The thing that I want to keep reinforcing is just the importance of doing the lifecycle management. So whether it be at the very front end of the manufacturing process, or whether it be, like I said, tracking who's doing what to bits that are going to land on the device. So like I said earlier, whether it be firmware updates, whether it be a configuration file change, whether it be an application, a reload of an application, how do I know that what's landing on that device is what I want to land on the device and it hasn't been tampered in the process? For auditing, who touched what at what point? Can I go back and verify who is involved? Some of our customers require at least 4 different entities to touch code from the time it's posted to the time it's actually deployed. So how do I validate and track all of that activity? And then for the back end, for the compliance related stuff, how can I run or collect information that's critical to my being able to adhere to those compliance or corporate governance standards? So how easily and effectively can I read out that type of information? So really in any phase of that life cycle, we have things that can help with those challenges. And I don't mean to propose or say that, by deploying Mocana, you're going to solve, FIPS requirements in a healthcare environment, because for me, adhering to those standards it's all about people, process, and tools. But what we can do is provide some of the requisite tools that are critical for being able to meet those, and we can provide information from those tools for the purposes of for the process component of reporting to ensure compliance adherence. And then just to, I guess, provide a little bit more detail, I've been talking about enrolling or device discovery, but what you're looking at is actually it's a screen capture from our user interface, and it really just talks about the different elements of the enrollment process. So if I'm looking at this, the enrollment service itself it's running in a container, so customers that want to use Trust Center, enrollment is one of the services that rolls up underneath Trust Center. It's basically, it's delivered in a container, so it's fairly very flexible as to where and how it's deployed, whether it be a private cloud, public cloud, combination of the two. Might be sitting on a device that's mobile, not a mobile as far as a phone, but might be on a loading device that would be used in oil and gas as an example. But the point is it's extremely malleable as to where it gets deployed. The real benefits the enrollment service is, and one thing I definitely want to be clear on, is Mocana is not a certificate authority. Rather, we want to use the certificate authority of choice for the customer. So whether they're using Microsoft or DigiCert or PrimeKey or Verizon, the fundamental question for us is which ones do you want to use, and which groups of devices or which tenants do you want us to apply these certificates to? So going back to the challenges associated with applying certificates between the enrollment service and our update service, we can really make that very transparent to the administrative, or what's usually associated with the administrative burden and overhead of dealing with those types of environments. And certainly for folks like healthcare comes to mind, because in healthcare, we've got a lot of devices that are connected to wired environments in critical care facilities that certainly have a high level of, or a heightened level of security concern. But the challenge, or intimation that meeting FIPS certifications in the future are going to be a requirement. Either way, challenge in that environment or those types of environments are A hospital is going to be likely part of a campus. That campus is likely going to be part of a healthcare organization. That healthcare organization is likely going to be using their certificate, a certificate of authority, whether it be public or private. But ultimately, if I'm a manufacturer and I'm shipping product to those types of environments, and I'm looking at or entertaining being a managed service provider for those environments, I need to have the flexibility of multi-tenancy and being able to map those certificate authorities to different tenants within my management purview. Or it might be similar for a healthcare organization, but ultimately what we do provide then is a very flexible platform as far as mapping desired certificate authorities to desired groups or locations of devices. And then we've built the platform bottom up with the expectation that this may be consumed by some other management platform. So anything that can be done through the UI can also be executed through RESTful APIs on the enrollment service. And then last but not least is the updating process. The enrollment process is really kind of it's not a set and forget, but commonly it's probably going to be used once over the lifetime of a device. It may be used again if the device is going to be, if there's going to be a transfer of ownership. I need to move the device from site A to site B, or it might be from customer A to customer B, or whatever that requirement is. Or I may want to brick a device for whatever reason. A quick way that we can do that is just to revoke the certificate and then basically take the device off the air, so to speak. That's the enrollment piece. The update piece then goes to the piece that I was referencing earlier, which is how do I make sure that the bits that land on the box are the bits that I want to land on the box, and not ensure that they have not been tampered with through that entire sequence. From a trust center perspective, we break that into different phases, if you will, as to who's touching what when. On the left side, there's a provider service, and this is where those folks that are responsible for getting bits or software, firmware, configuration files, application updates, whatever they might be, onto a device are presented with a portal where they're going to post this desired image or configuration file, etc. Once posted, we basically sign and encrypt that package, if you will, or that artifact that's going to end up on a target system ultimately. At that point, their job is more or less completed. Any number of providers or entities within a provider can be contributing to a device. So I might have someone that's focused on operating system doing firmware updates. I might have someone that's focused on the configuration of the device, or might be someone focused on application updates. But there's likely going to be several different entities that are going to be feeding things into a system that need to end up on a device ultimately. So from there, the provider's job, once posted, is more or less completed. As I move to the right, there's another functional responsibility, which we call publishing. So here, a publisher would be the entity that's now going to assume responsibility for the package. They will further craft the package that's to be deployed on the device. And it could be some number of packages that end up on a device, but at that point there's a transfer of ownership. The next entity in that chain is now going to, actually unbeknownst to them, is going to actually ultimately end up re-signing and re-encrypting that package. And we basically contain that, keep that process going all the way to the time of deployment on a device. So going back to what I was saying earlier, from our perspective, it really becomes more of a workflow question than it does anything else. So if a customer has a device that's air-gapped, partially air-gapped, is connected over unreliable transport, or is connected over, not unreliable, but call it untrusted transport between devices, or connected over a dedicated, nailed-up, wired infrastructure, for us, we don't really care. It really becomes more a question of what does the workflow need to be? Because ultimately, once we have the binaries running on the target device itself, we can basically ensure that unless the package that is to be loaded is not from a known, trusted entity, we can basically make sure that software package will not load in the first place. So, that's more or less what I wanted to cover today. So from that perspective, we're through the content I wanted to go through. I'm looking at the questions from the audience. I don't see any questions. No questions have come up. Maybe we'll give it another moment to see if anyone wants to post a question. As we're waiting for that, as I mentioned earlier, if you'd like to get some more detail about, I kind of went through some of this stuff, and arguably I definitely did some hand waving as I was going through some of these topics, but if you'd like to get more detailed information about the actual how we're doing what we're doing, please feel free to send an email to info@mocana.com, and someone will get back to you relative to answering those questions, or possibly setting up a meeting just for the purpose of getting far deeper into the technology. To start the call, I mentioned this call has been recorded. We will be posting it and sending it out via an email link, so you'll be able to go back and review this at your leisure. And while I was doing the housekeeping stuff there, we did get a question. So the question is, how hard is it to implement? The binaries themselves are actually very straightforward. My question there is really how much memory, how much storage is available, because they're basically going to take up about 2 megabytes of flash, and then peak utilization is just going to be just over 200 kilobytes. So I just want to make sure that there's enough memory for the binaries to run in. How they get on the device, if there's a device management system that's currently being used, we can leverage that. We have a solution that we can also use to do brownfield client installation, so we actually can present a mechanism for doing that in the field. And or if a technician is putting their hands on a device to do some other activity, we could be part of that process. So that really gets back to the workflow question that is usually my first question I ask of a customer is, what is your current workflow, and how do you get bits on a box, or how do you get configuration on a device? How hard? Oh, so sorry. That's for what we call trust point, or our binary. And I don't want to I don't want to frighten anyone. It's just that for systems that are resource constrained, there's just no other way around it. A solution has to be custom built, so that is non-trivial. In some of the more extreme examples, we've gotten software on a device in literally under 1,200 lines of code, running under 60 kilobytes of memory on a real-time operating system where CPU cycles are precious, and that when we're doing certificate authentication and a level of encryption. That would be one example. But that's non-trivial, but that is in that example, that we're talking about a system that is highly, highly critical. So that one really, the challenge isn't one of cost or complexity, that's one of criticality, and this is a system that human lives literally depend on. So there's two ends of the spectrum. There's stuff you can just drop in a box, and I would argue that from the time that someone took our binaries, came up to speed on our user interface, which we call Trust Center, and went through a level of testing rigor, I personally feel that unless there are just some really unique requirements, one could easily get through that entire process from test to deploy inside of 3 weeks. So that kind of leads to the next question: is how hard is it to try the solution outline? We present Trust Center, or we have it hosted in AWS. Actually, I'm glad I said that. So we're not looking to deliver this as a service. That said, we have Trust Center running in AWS for folks that want to do some sandboxing or testing. We can present Trust Center from AWS. My experiences to date, for someone that has a decent background, and I'm not even talking about an expert, just somebody that's got decent experience with these types of systems and or keys and certificates, the knowledge transfer is literally hours, 2 to 4 hours tops. So once again, the difficulty there is it's really just more taking the time to learn a new user interface and how we actually deploy and manage the keys and certificates on a device. Does this work for on-premise only solutions? Well, the devices themselves are going to be on some premises somewhere, so the answer there is yes. For Trust Center, that can run in a cloud. It can run in a private data center, private cloud. It could run. I don't mean to trivialize it, but sitting on my desk is an Intel NUC. I've got Trust Center running on a NUC on my desk, so it really becomes a question of where it needs to be deployed. So I guess that would be a long-winded yes. And yes, it is absolutely designed to work with mission-critical systems. I'm sorry, the question is, actually I can't read the whole question, I can only see part of it. Mission-critical systems will not work with any internet-connected or over-the-air service. Is this compatible? Yes. That goes back to the how would you like to deploy the package? In that type of environment, it is whether it be over the air, if it's not physically connected, we're now into an air gap scenario. So whether we drop the desired package on a USB stick or we post it somewhere for a loading application to consume and deploy, like I said, it really becomes a question of workflow. Please speak any short comments on your security processes and protocols. That's kind of a conflict. Short comments on security process and protocols. Sorry, I don't mean to make light of the question by any stretch, but I've got about a minute left, so that would be extremely difficult. If you send me a note at info@mocana.com, happy to respond to that one with a little bit more depth. What certificate authorities right now? Microsoft, DigiCert, Verizon, PrimeKey. We have connectors already built. For us, it'd be very straightforward to leverage something else. Is easy to add other CAs not yet supported via, yes, sorry, is it easy to add other CAs not yet supported via PKS CS11 protocol? Yes, it's very straightforward for us to build a custom connector for a desired CA, as long as they've got usable APIs. From our experience has been that it's not that hard for us to do if needed. When working with medical device manufacturers, do you operate under a SaaS model? How do you differentiate costs of your service on the wide variety of medical devices that companies may deploy? What is the average range of pricing per device? Well, the last one is, well, I've spent a career not getting into pricing conversations, but the short of it is we basically license it based on Trust Center and some tiered number of devices, aggregate devices, is the short answer. As far as the next question, I'm going backwards on the questions. How do you differentiate cost of your service from the wide variety of medical devices? Yeah, for us, it's really just a device count. It does get a little bit non-standard once again, if we're talking about binaries versus what we call trust core or source code and libraries. But that really is a function of what are those devices, because some devices we flat out may not be able to, or there may not be a value proposition that we have, but rough order of magnitude, list pricing somewhere in the $10 to $20 per device range. And then the first question of the three was, when working with medical device manufacturers, do you operate under a SaaS model? No, we're currently not a SaaS company. I just mentioned that we do have Trust Center running in AWS, but that's really to help facilitate initial testing of our platforms, field trials, etc. It is designed to run in a cloud, so if someone wants to provide a managed service for healthcare, our goal is to make it easy for them to consume and turn around. And then there are several service providers that we're working with today, spanning industries. So if the question is one of interest around an entity that could outsource the management, I'm happy to help connect whomever with a service provider that can do that. It looks like I need to take the last question because I just saw a timer come up that says I'm about to get hung up on. Let's see. Sorry, join late. If possible, please. Oh, yeah. Sorry. This goes back to the security question. I'm happy to answer that, but the clock is literally going to kick me off here. So if you could just send a note to info@mocana.com, and I'm happy to answer that question in quite a bit more detail than I'd be able to in the next 30 seconds. With that said, once again, I think I've said it 15 times. I'll say it one more time. If you have further interest, please feel free. Just send us a note at info@mocana.com, and we will be sending out a link with the recording for those that registered for today's session. For those that were on the call today, I definitely very much appreciate your time and wish you the best of luck. Thank you.